We're now going to begin the process of translating our simulation into components that Unity can render to the screen. The first thing we need to do is make sure that our project is using the Universal Render Pipeline asset we set up earlier. To do this, we need to open the project settings under the Edit menu, and then under the Graphics section we can choose our new pipeline asset. Now that we are using the Universal Render Pipeline asset, we can set up a custom transparency sort axis using the 2D render asset that we created earlier. In order to create the illusion of depth on our isometric tile map, we need to sort the tile map sprites along the y-axis. To do this, we can define the transparency sort axis with an x value of 0, a y value of 1, and a z value of 0. Since this is the most common custom axis, it's currently the default. Now we can begin building the tile maps that will make up the rendering component of our world map. We'll begin by creating an empty game object to serve as the parent for the world rendering components. We'll call this object World. Underneath this object, we'll create an isometric tile map object, and we'll name it Ground to represent the ground layer of our world map. This will automatically place a tile map grid object into the scene as well. We will place the other tile map layers under this same grid object. We're going to quickly reset the transform component of the world object so that everything sits at the origin of the scene, and then we'll move the grid under the world object we just created. We also need to set a few options for our tile maps so that they render correctly. First, we need to set the mode of the tile map renderer component to individual. If we left this as chunk, then the tiles would be rendered in large groups, which would override the custom y-axis sorting we just set up in the render data. We want the tiles to be rendered individually so that all of the tiles at a certain y value can be rendered together. This will build up the tile map row by row to create the illusion of depth. Now, we'll add the other two tile maps to our grid object. First, we'll create the structure tile map, and then we'll create the overlay tile map. We need to set both of these tile maps to individual mode as well, and then we also want to change their order in layer so that they appear on top of the layers below them. The ground tile map will keep the default value of 0, the structure tile map will have a value of 1, and the overlay tile map will be given a value of 2. This will stack them on top of each other when they are rendered. Finally, we need to add a light to our scene in order to be able to see anything at all. We are going to use a global 2D light, which simply fills the entire scene with a constant light value. We will also place this global light underneath the world parent object. If you do not see these 2D lights available, then you will want to check to make sure you set up the Universal Render Pipeline correctly. We set up the assets in the first video of this series, and we connected the asset to our project at the beginning of this video. Now we're going to introduce the component that will render our simulated world to the screen. Let's create a new script under the Components folder called World Render, and then we'll attach this script to our scene using the World game object. Let's open the script in the editor and begin setting up our tile map resources for rendering. Let's introduce the Unity Awake callback into this component, and also remember to add the script into our root namespace. Now we're going to introduce a number of variables that will hold references to all of the tile map objects we just created in the scene. We are going to build our world map procedurally in code, so we need access to all of these resources in our script. We will define a reference to hold the grid component, and we will also define a tile map reference for each layer of our tile map. Make sure that you import the Unity Engine Tile Maps namespace because the tile maps are not part of the root Unity Engine namespace. Next, we also need a dictionary of all the tiles we have available to use in each layer. This will be like our tile palette, but it is defined in code. These dictionaries will map our simulation tile types to the actual Unity tile assets that will represent those types when they are rendered. This helps maintain the distinction between our model, the simulation, and our view, the Unity render component. This way, the simulation is not aware of how it is being rendered. The world render component simply takes the list of tile types that are being used by the simulation and it maps them to tile assets it can render using these dictionaries. Let's define a private method that we can use to set up all of these references. We will name this method setupTilemapResources, and we will call it in the awake method of the component. Now, let's get each of these components by first getting a reference to the game object they are attached to, then calling getComponent on the object to get the component reference itself. To find each game object, we can use a static method in the gameObject class called find that looks for a game object based on its name in the scene. The next thing we'll do is define the dictionaries of tile assets. We will do this by mapping each of the tile types to a tile asset that we load from our resources directory. Conveniently, if a tile asset is set to null, then the tile map will render nothing in that position, which is exactly what we want. In order to load assets from the resources folder, we can use the static method load, which is in the resources class. We will now repeat this process for the other two dictionaries. This completes the loading of our tile map resources. We are now ready to define an event in our simulation that we can fire to let the world render component know that we want our map to be rendered to the screen.